In a lateral sense, computing refers to the use of computer hardware to process input data and option output. Paradigm generally refers to a style with certain specific characteristics. For example, there are different programming paradigms for programming languages, including procedural, object-oriented, function, and logical. So the computing paradigm I understand is computing style that is compatible with certain hardware structure used to perform computing tasks. This report focuses on the object-oriented programming paradigm. OP is based on key concepts such as classes, objects, inheritance, encapsulation, polymorphism, and abstraction. Object-oriented programming promotes program flexibility and maintainability, and is widely used in large-scale project design because it makes it easier for people to design and maintain programs, and makes programs easier to analyze, design, and understand. OP model real-world entities and relationships through objects and classes, enhancing the intuitiveness of the design process. By encapsulating data and behavior in objects, OP promotes spell-reaction of concepts and enhancing the security and the integrity of the code. Inheritance allows hierarchical class structures in a building code race and extension without modifying existing code. Polymorphism and abstraction further enhance software flexibility and extensibility by allowing object interchangeability and focusing on high-level interfaces rather than specific implementations. This summary provides an overview of the OP paradigm, highlights indefinite characteristics, and explains the retainable for a deeper exploration. Through this examination, we aim to shed light on the strength and weakness of OP and its relevance in contemporary software development.
Object-oriented programming 1. Definition and characteristics. Object-oriented programming is a paradigm that shifts the focus from products to objects. Objects encapsulate data and behavior, promoting code modularity and reusability. OOP introduced the concept of classes and inheritance, allowing developers to model real-world entities and relationships.
Okay, so for the detailed discussion of OOP, object-oriented programming is a programming paradigm that uses object and class to code. Object is the combination of data and behavior, but a class is the template for creating objects. The architecture consists of 5 parts. The first one is class. It is a template for creating object. For the second one, object is an instance of a class and is created from a class. The third one is encapsulation. It is a band of two methods that operate on it and hide the implementation details of the object from the outside. The fourth one is inheritance. It is used to inherit the properties and method of the superclass. It can also add a new one or override the old one. The fifth one is the polymorphism. It also allows different objects to accomplish the operation with different way. For the strengths and weakness of detailed discussion of OP, we shall begin with the strength. It can enhance code reusability, promote code modularity, and easier maintenance and scalability. For the weakness, it can steeper learning curve, potential for auto design and performance overhead, especially with many objects. And to compare with procedural programming in structure, OOP can provide a clear modular way to organize your code. But in procedural programming, it has a simple and less modular structure. In maintenance, due to the modular structure, it has a high maintainability. But in procedural programming, it has a poor maintainability in large projects, and it is also easy to cluster.
The paradigm I favor is object-oriented programming OOP. It offers a structured approach to software development, promoting modularity, reusability, and ASAP solutions. So its patents abstractions enables a clear representation of real-world intents in code, enhancing both design and maintenance efficiency. However, it's important to acknowledge that OOP also has its limitations, such as the potential for overdose and a steep learning curve for beginners. Nonetheless, its widespread adoptions and flexibility across various domains underscore its enduring significance in modern software engineering practice. Here are our group opinions on the pros and cons of various aspects of paradigm programming, include code organizations and modularity, maintenance and scalability, performance and resource management. And the last is flexibility and adaptability. That's all.